Today we are going to talk about water source heat pump systems and some things you should be aware of when you are installing new controls on the components of the water loop. The term heat pump technically applies to all DX systems. The standard refrigeration cycle used for cooling pumps heat from the inside of the building and rejects it to the outside air via the condenser. That is a conventional air-to-air heat pump, but hardly anyone ever refers to a conventional cooling-only DX system as a heat pump. When you hear someone say heat pump, you should think of a reversing valve on a DX system that can provide heating or cooling. The reversing valve switches the functions of the evaporator coil and the condenser coil. In cooling mode, the indoor coil can correctly be called the evaporator coil and absorbs heat from the indoor air. The outdoor coil, which can correctly be called the condenser coil, rejects the heat to the outdoor air. But when the reversing valve is called into heat mode, the outdoor coil collects heat from the outdoor air and the indoor coil rejects heat into the space you are trying to warm. So your evaporator coil is actually outdoors when you are in heating mode. On an air-to-air heat pump, you must have a defrost board because ice will eventually form on the outdoor coil and will need to be melted periodically. A water source heat pump has no need for a defrost board. No ice will ever form around the coil when the unit is in heat mode. The temperature and flow of the water loop will prevent that. You might think that a heat pump would have trouble pulling heat out of 40-degree outside air in the wintertime. If it feels cold to you and you want to put on a jacket before going outside, how is there enough heat available to be collected by the heat pump to then heat your home? The answer lies with the boiling point of the refrigerant. The boiling point of R410A is negative 54 degrees Fahrenheit. It is so low that there is still enough heat in the outdoor air to initiate a change of phase in the refrigerant. When the refrigerant boils, it is because it has absorbed heat. When the refrigerant condenses, it is because it has released heat. No matter what style of heat pump you are using, the evaporator will be fairly effective at absorbing heat when the ambient temperature around the evaporator coil is 40 degrees or above. This is dependent on the type of refrigerant used in the system, but R410A is most likely what you will encounter. It works well in many climates in the United States. There are refrigerants with much lower boiling points. In fact, heat pumps can even operate in Arctic climates. They use R744, a CO2-based refrigerant, which has a boiling point of negative 108 degrees Fahrenheit. We have already covered where an air-to-air heat pump rejects its heat. So now let's look at where a water source heat pump absorbs and rejects its heat. One of the coils is exposed to a water loop, and the other coil is exposed to the air that circulates through the occupied space. The water loop travels to each of the water source heat pump units all throughout the building. In swing season, where rooms on the exterior of the building may need heating in the morning, and rooms on the interior of the building may need cooling, the heat from the interior will be rejected into the water loop and can be absorbed by the units serving the exterior of the building, making the water source heat pump system more efficient than the air-to-air heat pump. The water loop will also flow through a boiler to raise the temperature of the water in winter, and a cooling tower to lower the temperature of the water through evaporation in the summer. The loop should be kept between 60 and 80 degrees. The cooling tower can be closed loop, where the building water loop flows through a heat exchanger, either in the cooling tower or in a mechanical room nearby. The water in the building loop is never exposed to the outside air, but tower water will circulate across that heat exchanger to absorb heat and then be pumped outside and sprayed over the honeycomb-shaped fill inside the cooling tower to take advantage of evaporative cooling. Or the cooling tower can be open loop, where the water from the building loop will be sprayed directly over the fill and some of it will evaporate. A closed loop system should never lose any water and will need very little makeup water introduction into the building loop. An open loop system is constantly losing water to evaporation and will need plenty of makeup water to keep the system operational. Here are some things to keep in mind during the installation of new controls on the central plant. The water loop needs to be pumped around the building constantly in case any of the heat pump units get a call for heating or cooling. If the flow of water stops while the unit is running, it is possible for a high pressure or low pressure condition to occur and trigger a mechanical safety. Some of these safeties will reset on their own once the pressure has normalized, but some will need to be reset manually, requiring a technician to go to every unit on the loop. So it's important to keep the pumps running as you are installing new controls on the central plant. Put the pumps in hand during the swap. Don't forget you may have separate pumps for the building loop and the tower loop if you are working on a closed loop system. The tower loop pump is sometimes referred to as the spray pump. When installing a thermostat on a water source heat pump, keep in mind the unit may not require the thermostat to control the reversing valve via the W1O terminal, as is associated with most heat pump applications. We sometimes find that the unit will require conventional wiring, and a logic board inside the unit will control the reversing valve to put the unit into cooling or heating mode based on the signals coming into Y or W. This is referred to as a heat pump wired conventionally. Wiring diagrams for either application can be found inside the manual provided with your Pelican thermostat. The Pelican TC1 thermostat can be wired and configured to handle either type of unit. You will also want a Pelican TA1 and T1 duct probe to measure and report the supply air temperature. If the unit has an economizer, you will need a Pelican Pearl in place of the TA1 to control the economizer damper based on outdoor air conditions. The Pearl comes with required sensors needed for supply air, return air, and outdoor air temperature measurement, and can be configured to control the economizer to your specifications using the Pelican web interface. For constant volume applications, control of the boiler, cooling tower, and all related pumps can be achieved with the Pelican Power Control module. If flow interlock control is desired, a TA1 can be placed on the same data circuit as the power control module to monitor a binary flow device. A TC1 thermostat and Pearl combination can be used to monitor the building water loop supply and return temperatures. If modulating control of variable speed pumps or cooling tower fans is needed, the Pelican plant controller can handle it. Once your new Pelican system is installed, you will have many thermostats which will need the plant to be operating before they can run heating or cooling. Once properly configured, the thermostats will send a signal through the mesh network to enable the plant equipment. Pelican wireless control systems are highly adaptable and in many cases can be tailored to your needs. Many wiring diagrams can be found in the documentation provided with your Pelican controller, or on the Pelican Wireless website. Also, custom diagrams for your application can be provided. Contact Pelican Wireless technical support to see what components will work best with your specific application and for help with configuration. Remember earlier when I said you needed special refrigerant to operate a heat pump in the Arctic? There is actually a way to use R410A in a heat pump in the Arctic. Next time we will look at one more style of heat pump that makes that possible. It's called the geothermal water source heat pump. The water loop is pumped deep into the ground where the temperature is a stable 50 degrees all year round. 50 degrees is an acceptable temperature for both absorbing heat from and rejecting heat to the water.